Welcome everyone to the SABR webinar on torpedo bats. Thanks everybody for joining us. It's a very hot topic at the moment throughout baseball. My name is Scott Bush. I am the CEO of SABR, and I'll be moderating the discussion this evening, joined by three amazing panelists to help us talk about this from several different angles. The first is Dr. Alan Nathan, Professor Emeritus of Physics at the University of Illinois. Welcome, Alan.
Thank you. Good to be here.
We've also got Keenan Long, co-founder and CEO of LongBall Labs. Welcome, Keenan.
Thanks for having me. Pumped. Let's do this.
And we also have Jed Lowrie, MLB All-Star and 14-year Major League Baseball veteran. Welcome, Jed.
Thank you, Scott. Thanks for having me.
So we're going to get to a lot of different discussion topics here, guys. But I want to start by sort of setting the table a little bit in terms of how we got here, because it felt like one day everyone's bats looked identical, and then another day a lot of players had bats that looked very different from what we'd grown accustomed to. So we'll start here with a very brief and an incomplete timeline, and this is a timeline that I would suspect as we continue to do a little bit of historical research on the subject, we're going to go much further back than 2024. But for the purpose of tonight, we're going to start there. And Giancarlo Stanton used a torpedo bat last season without people being fully aware of it. Now, there will be several moments throughout this conversation where we will be very careful not to attribute correlation with causation, and this is the first instance. So Stanton's OPS plus and weighted runs created plus increased greatly in 2024 compared to 23. He also had an amazing postseason and was instrumental in the Yankees reaching the World Series. So flash forward, we get through opening day, which was March 28th, and then March 29th, the Yankees have a huge offensive game. They hit 9 home runs. 5 Yankees playing in that game were using torpedo bats, and all of them hit home runs in that game. So here's a quick video, and I apologize if the audio is a little bit soft, but I want to share this for what was said during the broadcast.
A big barrel on it. Well, it's actually a little bit lower than the barrel. The Yankee front office, the analytics department, did a study on Anthony Volpe, and every single ball it seemed like he hit on the label. He didn't hit any on the barrel. So they had bats made up where they moved a lot of the wood into the label, so the harder part of the bat is going to actually strike the ball.
A weird way to hit, going up there expecting to get jammed and putting the meat of the bat towards the label.
It allow you to wait a little bit longer.
Yeah, your weight, all right, to take back.
So there's a lot wrong with how that was described, which we will get to in a minute. But suffice to say, the way that it was presented for the first time to the general public made it sound as if maybe there's a new cheat code inside of baseball bats. And I think that led to a lot of the initial interest and reaction around the country. So since that time, there's been a lot of reaction. The 3 big bat manufacturers have reported a lot of interest from their player clients. They're also retailing torpedo bats on their websites. And as of April 3rd, per Yahoo Sports, there were 17 players in Major League Baseball known to swing a torpedo bat. That's something that is fluctuating probably fairly regularly at this point, as guys are prone to trying out different bats. So final thing as we set the table here, and we'll get to our panelists, the rule book. So here is the Major League Baseball rule book governing bats. It is short, it is sweet, and it leaves a lot of room to try things if one should want. So, Jed, I'd love to start with you,
Yeah.
and would love to hear some of your experiences throughout your career in selecting bats, what went into that, and maybe who was involved in that process for you.
Yeah, it was an evolving process for me up until I worked with a bunch of different companies and ended up with Pete Tucci at Tucci Bats. And early on, you think you've got an idea of what type of model bat you're going to use throughout, based on your experiences in the minor leagues and trying things out in the off season. But as I developed my relationship with Pete, we started to customize what ended up being the same bat for me from each side of the plate. I had two swings to manage, so I was trying to be, as simplified as I could and swing one bat from both sides of the plate. As that process continued with Pete, I was introduced to Keenan, and the last couple of years of my career, I was able to work with LongBall Labs and further explore some of the data behind bat science.
Excellent. Keenan, this would be a great time for you to jump in and share, I think, first with everyone what LongBall Labs does.
Sure. LongBall Labs is basically weaponizing the variation that exists in wood bat production to create an advantage for players like Jed, who was our first client. Thank you, Jed. And thank you for letting us keep some of the bats at the end of your career. They've been great demonstration bats for meeting new clients and showing them what we can do. So what we do is the result that we gain for our players is converting warning track flyouts essentially into home runs. And we do that because no two bats are the same. No two individual bats, even if they're labeled as exactly the same, they have other parameters way beyond length, weight, and turning model. And those parameters vary pretty wildly. Jed, I pulled some of your numbers.
Yeah.
Your ideal bat barrel mass, and then I checked all of the other bats that you got that we looked at that were the same turning model. And the barrel masses varied by over 2.1 ounces. Now, in testing with players where they're actually swinging the bats, we see 1/4 of an ounce is the threshold where exit velocity starts to get affected. So yours varied by 2.1 ounces. That's over 8 times that threshold. So that's one of the things that we do at LongBall Labs just talking about details for a second. We need to dial that in, that one bat metric, along with all the others to make sure that you get what you earned at the plate. And what we've done since we've worked with Jed those years ago, we've grown a little bit from that. And in Jed's case, we were saying, here's what the factory made. Like, here's what it was. Sorry, here are the cards you got dealt. Now we're working with the factory to make sure the players get dealt good cards that match with what their optimal parameters are. So doing so can create a major performance advantage. And that's the long and short of LongBall Labs.
So, Keenan, you're speaking to variance inside of the weight of the barrel itself. So, right? So
as one metric, yes, one of the metrics that we need to manage.
Right. So, so within that, let's pivot to the torpedo bats.
Sure.
And can you describe sort of the change in shape and what that means, and a little bit about what players may be hoping to gain by using one?
Totally. I would say the torpedo design, like any other bat design parameter, it comes with trade-offs, and they have to be evaluated in the context of the player using them. And so, like, LongBall Labs has analyzed thousands of bats for major league hitters and then worked with those hitters to do performance testing, much like we did with Jed. And what continues to be the biggest variable is the player themselves. So that means Jed's absolute optimal bat parameters could really not help another player if another player picks up Jed's bats. So I wanted to say that. And then one other little factoid about torpedo bats. If we define a torpedo bat as a bat whose barrel diameter is less here than it is here, then there are big leaguers right now swinging torpedo bats that don't even know it. Because bat companies do that. There are turning models for which this area has a smaller diameter. It's just not as dramatic. So I think, I mean, at some point we should define what reduction in barrel diameter over what span of the barrel is constitutes a torpedo bat and what doesn't.
So well, this is the perfect time to bring in Dr. Alan Nathan. So Alan, how, from a physics perspective, at what point do you feel like you hit the tipping point of saying this is a torpedo shaped bat versus a traditionally shaped bat?
I haven't really thought about it quite in those terms. I was simply interested actually in understanding it, the sort of the dynamics of how the bat performs, as opposed to just defining what is meant by a torpedo bat. So, I mean, I've been doing studies of bats for a long, long time. I've developed a simulation code that can be used to simulate the ball bat collision. And I go beyond the simple approximation where you're only looking at the what I call the static properties of the bat, the weight, the length, the weight distribution, to look at the dynamic properties, which is the vibrational properties of the bat, and how those might be different for the torpedo bat as opposed to a more conventional bat. And if they are they different, number one, and how does those, if there are differences, how do they contribute to the actual performance of the bat? I should point out, I was showing you guys this earlier before we went on the air. I have a bat here in my hands, and notice, as Keenan was saying, this bat is tapered at the end. It's not bulging out here, but it's definitely has a larger diameter here than it does at the end. This bat is at least 20 years old. So the idea of this really is not a new idea. I would say it's newly adopted idea, but it's not particularly a new idea.
Right. I would agree. Right. It's removing mass from the barrel, which has been done in with other bat design changes, and has shown that it can be very beneficial for some players. There are also other players who need to have more mass added to the end of their bat, and that increases their performance. So finding out which one you are is very important, I think, as a player. This is the part of me that's a little bit worried about this trend and the human nature component of, look at this guy, he's out there frushing. I'm gonna pick up his bat and step up to the plate.
And if I was being critical and looking back on, right-handed versus left-handed, I would say that a torpedo bat may have helped me on the left side more than the right side, just with the swing dynamics that I had. And just anecdotally, I don't have any numbers to back that up. Just the, the way it felt in my hand and the way that I knew I performed as a hitter, it felt like, a little bit more mass towards the label would have been more beneficial from the left side for me, where more mass towards the end would have been more beneficial from the right side.
So what do those properties mean, Alan or Keenan? What do those properties that Jed's talking about, mass towards the end or mass towards the middle, what do they mean in terms of swing performance and the way that the player would be attacking the ball?
Yeah, go ahead, Keenan.
I would say if you're going from a regular design to a torpedo design, you're taking this point, which is the point of maximum performance of the barrel, and it's going to go this way. So that's one thing that has been talked about and written about that I would say is pretty widely accepted, and it makes sense. There's a lot of other stuff that doesn't make sense, but let's talk about what we know to be true. And that is, Dr. Nathan talked about the static components of the bat. So that would be the center of percussion, known as the sweet spot, the point at which when you make contact, and I'm sure Jed knows this, as a player, when you hit the ball just right and you feel nothing, you hear it, and you see the ball jet away, but you don't feel anything, that's when you've hit the ball in the center of percussion. Dr. Nathan also mentioned the dynamic characteristics of a baseball bat. So that would be the and Dr. Nathan, help me out here. Second node of the bending mode of vibration would move, theoretically is going to move this way as you remove mass from here and have a bigger bulge over here. I'll let you take it. Because you are on my Mount Rushmore of bat physics. I've got a Mount Rushmore. I want to talk about this at the end and get your Mount Rushmore. See if I'm missing any, but we'll stay on topic here.
Fair enough. Thank you. All right. Yeah. So the thing that I call the dynamic properties of the vibrations of the bat. So the thing when you don't hit the ball doesn't hit the bat on the sweet spot, you feel it in your hands. Jed, I'm sure, has felt this many times. And what you're feeling are the vibrations of the bat. And those vibrations represent energy that the ball transfers to the bat that is removed from the ball. So it decreases, in effect, decreases the exit velocity of the ball. So you want to minimize those vibrations. And what Keenan showed is, the spot on the bat that basically minimizes those vibrations. And it comes, there are various modes of vibration of a bat. And the minimum, and you're exciting several of them, okay, from fairly low frequency up to about 2 kilohertz in frequency. And the minimum of those vibrations comes at about what is called the node of the second vibration, which is what Keenan said. It's typically about maybe 6 inches in from the end of the bat. So but it varies depending on the shape of that bat and how the weight is distributed. So when you remove mass from the end and build up the mass somewhere further in, you're actually moving that sweet spot in towards the ladle of the bat, and so that affects things. And if that's where you want, if that's where you feel best making contact, then you're putting more mass behind that collision at the spot where you're planning to make the collision. You're removing mass from the end of the bat, which is pretty useless anyway.
Right. I have a question to add to that about the bat speed. So the reporting is bat speed goes up, which makes sense. Bat speed goes up when you remove mass from here. If we're taking the point of maximum performance of the barrel and moving it this way, isn't this part of the barrel moving technically, physically slower in a swing of equal swing speed because it's closer to the hand and thus rotating around a smaller arc? Is that something we should take into account when we're considering the trade-offs?
Absolutely. So when you move the mass in close towards the hands, okay, you're increasing the angular velocity, if you like, the rotational speed of the bat, because you're sort of rotating that bat, at least near contact, about a point somewhere near the hands. And so when you do that, the speed is higher at the tip of the bat, lowest as you move further towards the knob of the bat. So you're doing two things that go in the opposite directions. You're increasing that angular speed, that's good, but the lever arm between where the rotation axis and where you're trying to make contact, you've reduced that because you move that a little closer. And how one plays off against the other, I would say, is very, very batter dependent. I would guess there's not a one size fits all, and you really have to test it to know. I mean, it's not at all obvious that you're going to end up with better bat speed at the sweet spot, or maybe worse bat speed. You just simply have to you have to look at it for a particular bat design and for a particular batter swinging the bat.
So it's entirely possible, Dr. Nathan, that if Jed did in fact follow his own advice that he gave himself earlier, and he swings an end load bat from one side of the plate, and he swings a mid load bat or a torpedo bat from the other side of the plate, we may see that torpedo bat on measurement have a faster swing speed, but the sweet spot might be moving at the same speed in both swings.
It could, yeah. Again, it depends how that bat is designed. and how that batter swings the bat. So, as I said, it depends on where that rotation axis is, which could very well be different when you're batting left-handed versus right-handed.
Mm-hmm. The other thing I was thinking about lately, you know, that as velocity has increased in the game too, reaction time has been reduced. Maybe there's more guys that make contact towards the label simply because of the velocity in the game. I don't know if there's anything to that, but you know, seemingly there's less, even less reaction time.
Yeah, I mean, so again, just speaking sort of qualitatively, if you've reduced the weight, if you've moved the weight in towards the hands, aside from higher bat speed, you're going to have a quicker bat. There's almost no doubt about that. You're going to be able to get around quicker, which allows you probably to make good contact more often, regardless of whether you get a higher exit velocity. You're going to be able to square up probably more often. And that may very well be the major benefit of these bats. I don't know. We'll have to see, but it is definitely a benefit.
Yeah. Yeah. I've got some more data to share with you guys, but before we move off of this slide, the maximum diameter of the bat. Jed, do you know the diameter of the bat that you used when you played?
I don't. I remember Keenan probably knows. It's probably a better question for him.
You need to break out the calipers.
I do know that you know, like I said, I tried to simplify it as much as possible, and I was looking for the most balanced bat I could find. And so, you know, in my mind, it was an M110 with just a little bit bigger everything, right? Same taper, same, you know, barrel size, but just exaggerated. So bigger handle, bigger barrel, same taper.
And I can
Got it.
speak to the Jed's bat components, like the components of his bat order were basically required Tucci to like thread a needle. They had to pick exactly a billet that was an exact weight. And so they had to like kind of build up a billet inventory before they could cherry pick the right billets to make Jed's bats. Now, not everyone's bat design is like that. There are some bat designs that can be made with any billet, which is not a good thing for the hitter because then that means the bat's going to have varying, you know, bat metrics that we collect in the lab. So Jed, that was one thing I can tell you of all the people we've worked with so far. Your bats were the most special, as in the hardest for Tucci to make. And they were great about it. They said, here are the billets we got. We're going to make bats with these. And then when we get more, we'll fill the order.
Yeah. No, Pete, like I said, I was very grateful for not only for Pete's time, but his willingness to work with me through that process. Cause it got to the point where I very acutely understood how hard it was to source those.
Awesome.
Perfect. So we'll jump back into some data here. So these are the 5 Yankees that have been using a torpedo bat this season. So here is their average swing speed through Sundays, through this previous Sunday. And I've added the league average swing speed from 24, which was 71.5 miles an hour. And 71.5 miles an hour is basically the same as the average swing speed was for the second half of 23 when Major League Baseball first started gathering swing speed data. So we've got a season and a half that tells us we will be very close to 71.5 miles an hour, or we should expect to be at the end of this season for the league. So, you know, we can see here to varying degrees, each of the 5 has increased their swing speed so far. You know, Goldschmidt is the one that's seen the least amount of improvement. And again, I want to say 2 things about data this early. Number 1, very small sample. Number 2, again, players are working on a lot of things to increase their swing speed, not just changing bats. So I don't want to put this up as a, hey, look at what a torpedo bat does for everybody, because that's not the takeaway I'm trying to give here. So, but if we were looking for information about whether or not this has been effective for players, this would roughly be one of the things we're looking for, right?
I would
Yeah.
think so.
So one other item here, blasts. So for those of you at home who may be unfamiliar with blasts as a metric, so again, this is part of Major League Baseball's StatCast system. So Major League Baseball defines blasts as balls that are hit on the center and are hit on the center with a high swing speed. So it's one way to measure whether a player is consistently hitting the ball hard by hitting it where they're going to do the most damage and while they're swinging at a high rate of speed, right? So the 2024 average again is here. Last year, blast per swing league average was 10%. So you see, again, improvement across these five guys. Wells and Goldschmidt seeing marginal improvement. Volpe's had a great start to the season, so he's looking great in this metric. So again, I think one of the places that we would be looking to determine whether an equipment change had been positive, right?
Yes. Ideally, to have them test with their old bat and do a performance test to help support the on-field performance. But yeah.
Yeah, and
Right.
I think to add context to this and the last slide too, that, you know, as you said, it is a small sample with virtually no fatigue factored in.
Yes, that's great. That's a great point, Jed. Thank you for that. So Alan, you've got a few visuals here. I feel like maybe I should have put the first one up first, or earlier, I should say.
Yeah,
So here's the. Go ahead.
Yeah, okay, so some of you may know I had a Fangraphs article come out on Monday, and this image was from Davey Andrews. I think it was Friday's issue of Fangraphs, but I liked it so much I wanted to put it in there. And you know, if you look at a bat, you ask where along that bat do you want to hit the ball, and this shows you quite clearly. The stuff from the label on back to the knob is, as it says, total garbage. And maybe what wasn't appreciated so much, or maybe people hadn't thought about it, that the very end of the bat is not particularly useful either. I mean, it's very hard to make good contact at the very end of the bat. And, typically you get just little dribblers off the bat. So the basic idea is that you want to put as much of the weight as possible in that sweet spot zone, because that's where it will do the most good. And the analogy I like to draw is a golf driver, where that's sort of taking it to an extreme, where you've got a very slender handle that doesn't weigh very much, and all the weight is at the very end. But of course, the ball is not moving. So it's, you wouldn't do that with a baseball bat, but in principle, that's what you would want to do. You'd want to have all that weight where you're going to make contact and, reduce the amount of weight at the other spots. So with that in mind, I actually contacted one of the bat manufacturers, and I promised I wouldn't reveal who it was, but I managed to get from this manufacturer the shape, the profile of two bats used by the same batter, a conventional bat and a new Torpedo bat. And so what this next slide shows is how the diameter varies with the distance from the barrel tip. And you see the bulge at about 7-8 inches there. And the bats more or less coincide once you get outside of the tapered region into the handle. And you see that the Torpedo bat, the blue one on that chart, takes a dip at the very, very end of the bat. That's the taper at the end of the bat, and the bulge a little closer in. And so I said, all right, I've got this modeling software that I developed, dare I say, more than 20 years ago, more than 25 years ago. And I have used it over the years to a large extent to study aluminum bats, because that's where most of the action was in terms of the NCAA trying to regulate the performance of bats and things like that. And I hadn't used it for wood very much, but this is an opportunity to do that. So I said, all right, I'm going to model these two bats, and this is what I came up with. So what you're seeing is, so in order to model it, I need to make some assumptions about the vibrations. Okay, I made reasonable assumptions. I had to make some assumptions about how the batter swings the bat, in particular where that rotation axis is. But when all is said and done, you see that the standard bat and the torpedo bat don't quite look alike. You see the peak exit velocity at about 6 inches for the torpedo and maybe about a half an inch closer to the tip for the standard bat is not very different. As you might imagine, the torpedo bat performs less well as you go closer to the tip because there's less mass there. And it performs better than the standard bat as you go in the other direction. And the interesting thing I found that, quite frankly, I didn't expect, but this is what research is all about. You like to have surprises, because then, you could spend your time trying to figure things out. What I didn't expect was that the amount by which the torpedo bat exceeded the standard bat going towards the label was more than the amount by which the standard bat exceeded the torpedo bat on the other side. So in effect, you not only have you moved the sweet spot in towards the hands by maybe a half an inch or so, but if you talk about the width of the sweet spot, and again, you have to define what you mean by that, but just quite arbitrarily, if you just look at the part of the curves that's over 100 miles an hour, 100 being a good benchmark, you see that is a wider width for the torpedo than it is for the standard. And now, is that going to be true of all bats, all torpedo bats compared with standard bats? I have no idea. These are the only two I've looked at, but it's sort of given me motivation to try to get to find out the dimensions of bats other batters are using, so I could do similar comparisons. So it was a fun exercise to go through, and it produced what I thought was a somewhat surprising result.
Yeah, this is really great stuff, Alan. Really great stuff, and we won't ask you to share the player that you got the bats from.
Yeah, I promise. I promise I wouldn't.
Jed, what's your reaction to seeing this graph for the first time?
Yeah, I mean, I think it's compelling enough to me that I would want to try it and see what it feels like in my hand, because I think when you're the operator, so to speak, and you're standing in the box and all the weight of the world is on your shoulders, you have to feel confident with the bat in your hand. And so I think in a controlled environment, I would want to see what it felt like, and then maybe in the off season do some testing with someone like Keenan to see if what it feels like is backed up by numbers. But that the chart in and of itself is compelling.
I should point out these two bats have the same weight distribution. They look very different, but the so-called swing weight of the bat, which is sort of the technical term, is the moment of inertia of the bat that mostly controls how the bat feels as you're swinging it, is actually identical for these two bats, probably by design, because the batter who commissioned the bat company to make it probably wanted it to do exactly what you say, to not feel any different. And if it doesn't feel any different, then you don't have to worry about changing your swing. At least that's what I think.
Yeah, no, I players are a finicky bunch, and so you give them something new in their hand when the lights are on, and everybody's always looking for that edge, right? So you got to feel confident and comfortable with what you're walking up to the plate with.
Yeah, Jed, so from the sounds of it, you were not the sort of player that ever changed bats during the season.
From a model, no, model possession, and this is where, working with Keenan helped me understand the dynamics of each individual bat that I was getting to, is, kind of as the season went on, how I was feeling physically, how fatigued I was. I could keep the same bat, but know that the properties of that individual bat might, feel a little heavier, or feel a little lighter in my hand as the season went along. So I think having that, golden number that we talked about with Keenan, that like produced the highest exit velocity, and then being able to deviate from that based on how I'm feeling physically, and allowed me the ability to adjust based on how I felt.
Great. Well, we've got great questions in the Q&A. But before we go to those, I just want to ask our panelists, is there anything else that you guys wanted to cover or wanted to share with everyone before we go to some other questions?
Yeah, I have one point I'd just like to make, is that the graph that I showed you about how this bat performs, how these bats perform, is a calculation, okay? But myself and a group of other people are in the process of actually obtaining similar bats to do some laboratory type testing. And in particular, the kind of testing we want to do is where you do a high speed impact on the bat, and you could control where along the bat you hit, and you could sort of map out how that bat will perform in the field. And you can do that in the laboratory. So we're quite anxious to do that. And I suspect sometime over the summer, we'll be getting a lot of data about that. And we're going to know a lot more then than we know now.
Excellent. Excellent. Really looking forward to the 2.0 of this. That would be a lot of fun. That would be a lot of fun. So let's start with a question from Jordan here. So Jordan asks, with how open the rules of the bat specifications are, why do you think it took this long for someone to think about the method of moving more mass to the barrel?
I was asked that question by one of the many reporters I talked with over the last week. And my first reaction was, damn, I wish I would have thought of that myself. It's like sitting there right in front of me, and I never thought of it.
Dr. Nathan, you just needed 9 home runs from the Yankees. That's all.
Right.
There are certain teams that will kickstart things that others mysteriously do not. That's true. And I'll say, right, like we mentioned the cup on the end of bats, right, which became very standard practice. That's a different version of the same idea. It's just far less extreme, right?
Absolutely. I have a quick story on that. We had a player for whom would be a great candidate for a torpedo bat because the barrel mass and the distribution of weight in his bat was too high. It was affecting his swing speed. So we ended up, without changing his turning model at all, changed the billet that was being used to make his bat and changed the cup depth, and really focused on those and made sure that they did not vary. And he gained 3.5 miles an hour in performance testing. And then he had been getting a steady diet of high and tight four-seam fastballs. And instead of swinging and missing at those, he was yanking them out of the park. And so I think what we're seeing with the torpedo bats is something that has been done, just through a different route, through a different bat design change. And now we're seeing guys take it to the extreme with the torpedo design.
That's excellent. I'm just looking through. Here we go. Here's a great question from Phil. Keenan, why don't bat companies have their own LongBall labs?
LongBall Labs is a third party. So I just have to say this. We are the official bat optimization technology of 7 of the bat brands, but we do not have any affiliation. We don't necessarily push one bat brand or the other. We don't care what brand a player swings. We care most about making sure the player knows what they're getting and fine-tuning the things that are beyond length, weight, and turning model. So that would be my response there. We let the data and more important, even more important than the bat data that we collect on the bats themselves, the guiding light, the guidepost for all of this is the performance test with the player. Let the performance direct what happens to the bat design, what happens to the decisions that are made on the factory floor to fine tune the bats for that player.
So a question about center of percussion. So is the center of percussion the same as the sweet spot? This individual says research says that it is different, if I'm not mistaken.
This is a great question for like the panel of my Mount Rushmore of baseball physics people. Of course, Dr. Nathan, you're on that, and I want to know who else is on your Mount Rushmore. But I love this debate. This is like the nerdiest bat physics debate. Second bending mode versus center of percussion. Which one is the optimal impact location? And then someone else jumps in and says, they're less than a quarter inch apart on most bat models, and the ball mark impact on a barrel is bigger than a quarter inch. So, like, what are we talking about? I want to hear what Dr. Nathan has to say about all this. I'm dying to know the answer to this question too.
Okay. Far be it for me to contradict anybody, but it is what you say is true. You could imagine you could invent many different definitions of sweet spot. So the so-called center of percussion, the node of the second vibration, or wherever the vibrations are minimized, where the exit speed is maximized, and all those 3 points more or less coincide, just exactly as you say. So whether or not you believe the center of percussion has any effect at all, from the point of view of where the sweet spot is, simply doesn't matter because they all lie more or less on top of each other.
Yeah, about the width of the electrical tape that I hear on this bat.
Yeah,
absolutely.
Here's one tailor-made for you, Jed. Would a hitter ever choose a different bat based on a pitcher's pitch sequence? And I'll add to that, maybe even more situational. You touched on high-end velocity and its predominance throughout the league at the moment.
Yeah, I mean, I'm not going to speak for every major league player. That seems like a clubhouse manager's nightmare. First of all, and second, from a personal standpoint, I always wanted to play to my strengths, and so I wanted to be the most confident I could in the box at any given moment, and so whatever bat that I felt like was going to produce the highest possible exit velocity, if I do my job right, is the one I want in my hand regardless of the situation.
Awesome. We've got a pair of questions about choking up. These are great questions because I have a feel for where the answer is going to go, but doesn't choking up on a typical bat accomplish the same or nearly the same goal of bringing the weight closer to the hands? So Keenan, Dr. Nathan, I'm assuming the answer is yes, but you're also sacrificing leverage, correct?
I would agree. Yes, it's also the most low-tech solution here, and that doesn't take away from its effectiveness. So if it is effective, definitely do it. It has trade-offs like you mentioned, just like any other bat feature that you're picking out, bat component, bat metric. They have trade-offs, and choking up is used a lot to the player's advantage when the situation dictates and when the trade-off is worth it.
One thing is probably worth pointing out is when you choke up, which is sort of like making the bat shorter, you have less access to the outer part of the plate. So one advantage I think of the torpedo bat is you're not removing that weight altogether. You're just reducing that weight. So you can still protect the outer part of the plate. Maybe you're much more likely to foul the ball off since you're not going to make good contact anyway and just sort of save yourself for another pitch.
Right. Great. And then we've got 3 folks that very astute when we were showing the swing speed graphic sort of brought up the same thing that Jed did, saying that fatigue is not yet really a concern on these swing speed charts. And so, yeah, I think for the three of you that asked about swing speed and early season versus late season, I think that that's a big thing to monitor for all players, and particularly folks that were showing, anybody who's showing big time growth year over year. We don't have a pitcher. We don't have a pitcher on the panel, but we'll ask our panelists anyway. Do you think the rise in torpedo bats would change how pitchers would approach certain hitters?
Yes. I can give a firm yes, because there's a prior example. I have two sources from players and two sources from front office that I cannot name that have told me that when the puck knob phenomenon came about, which was just a few years ago, that there was a study and people realizing that players who picked up that design feature could be beaten at the plate in a way that they couldn't be beaten before, and that strategy was implemented. So I have a feeling we're going to see a similar sort of strategy come out.
Interesting. Very interesting.
And it makes perfect sense. Trade-offs. It's always about trade-offs.
That's right. Couple people have asked about whether the torpedo bats are more susceptible to break than a traditional bat. We've got a Cubs fan who seems anecdotally to have noticed that two of their guys, Nico and Dansby, have had a lot of broken bats lately.
I don't. Well, I'm not an expert on these things, but I wouldn't think it would necessarily lead to more broken bats, assuming that you haven't made the handle thinner, which since that's sort of the weakest point, that's another trade-off. You can move weight from the handle into the sweet spot too, but there's not much weight to move. So I don't see any reason offhand why there should be more breakage with these bats.
Got it.
Anyone wants to donate a bunch of bats, we could get some hard data on this, but the only way to do so is by destroying the product. I want to keep my Jed Lowrie bats. I don't want to break them.
Jed, does the Players Association ever engage around rules and bats or rules of bats? And is that something that occurs regularly, where the Players Association is passing along recommendations or guidance on things like that?
Yeah, there's a competition committee that both the league and the union are a part of. In my time, I never heard much chatter about bats. I think the broadly written rules that just provide some parameters. I guess I'm kind of dancing around the idea, just saying no. Because there are certain certain rule changes that are discussed. I've just never heard anything specifically around bats, but who knows, with all the attention that this is getting, that maybe that's a topic that they discuss in a future meeting.
Gotcha. Here's a question that is more research, but in a different domain. So Lachlan believes that the manipulation of the bat weighting is very similar to cricket, where concepts like this have been applied since the 90s. And a greater proportion of the bat weight on the cricket bat is situated around the middle. So just again, I think I was pointing out that there's a cricket connection here that we hadn't considered. It was another question pointing out, why didn't we do this before? And we can only make Dr. Nathan regret things for so long tonight. So we'll keep it moving.
Well, based on the R161 he showed earlier, it sounds like this has been around for longer than what we've thought.
Actually, let me just say, I want to give some credit to Terry Bahill, who wrote a book on the science of baseball. The first edition came out in maybe 2013, 2014. And I don't know if what I'm about to say is in that, but there is a second edition from 2019 where he actually talks about moving, about tapering the bat at the end and moving weight into the towards a sweet spot. His goal was to have a larger diameter, to increase the diameter to the maximum allowed, 2.61 inches. I don't, Jed, you would know, but I think probably most major league hitters are using maybe 2.5 inch diameter.
Slightly less, yeah, less than the max for sure to hit weights back into.
So one of the advantages, if you want to take it that way, is by tapering the barrel, increase the diameter to the maximum allowable, and then the advantage that you have is simply a larger hitting surface. You're more likely to square up on a bigger surface than a smaller surface.
I'd like to insert a couple more fun facts about the Torpedo, just like the history. There's a couple really interesting ones. One, as a former Easton engineer, I could tell you there was a training bat that was called the Easton Torpedo that was shaped very similarly to what we see in these torpedo bats. It was in the line for a while. I believe it was a training bat that had a certain story behind it. And then also, there were performance bats made by Easton and by other companies that had a barrel diameter that went up to the point around the hitting surface, and then it actually decreased the diameter, similar to a torpedo bat. The non-wood bats right now don't have that. Excuse me, but this was a few decades ago that design in non-wood bats existed, proliferated, and is well known as one of the like rocket bats of that time. So.
Yeah. For those of you on Twitter, I retweeted a photo of the Easton Torpedo training bat into my feed a few days ago. It's out there. It's definitely out there. But maximizing that barrel size, Dr. Nathan, the bat that I would love for someone to get their hands on is Giancarlo Stanton's, simply because we would expect him to be swinging one of the heaviest bats in Major League Baseball. And if he made a transition into a torpedo style bat, if you look at photos of him, the screen grab from game 1 of the World Series where he hits that towering home run and he stands at home plate and he's holding the bat out, you see very little taper on the end of that bat. And that suggests to me that maybe they were getting very close to maximizing the barrel size on his bat because he's strong enough to swing something that heavy.
Yeah, one of my goals in the next week or so is to contact his manufacturer and get his bats to do the same kind of study I did on the other one.
Yeah. So speaking of Stanton, we've probably got no fewer than a dozen questions about injuries. We don't have an athletic trainer on our panel or a biomechanist, but do you panelists feel as if there could be injury concerns by changing where the weight is on a bat?
I have a quick opinion on this. If anyone has ever tried to throw a wiffle ball as hard as they can, even if they're in season and they're a baseball player, you can kind of hurt your arm from that. And I was talking with a person who is a specialist on this. Will Carroll did an awesome piece on this topic. And that same mechanism of injury could be something that's at play here, where you dramatically decrease the barrel mass by removing the mass at the end of the barrel, which has a huge effect on the swing. And if Giancarlo Stanton, already a prolific swing speed monster, now gets an even bigger increase in his swing speed, then perhaps parts of his body are now moving way faster, seeing way higher loads, and that could be a mechanism for injury. I'm only telling you that that's what I saw. I don't have any data on that to share, but I would refer you to Will Carroll for sure.
We've talked about barrel diameter. from a physics perspective, Dr. Nathan, how long could you, or how wide, right? We saw the piece of electrical tape on the marking the sweet spot on the bat here. What sort of specifications could you make on a bat to make that wider?
The width of it along the barrel, you mean?
Yes.
That's a good question. I mean, so far, I personally have not tried to design a bat, but that would be definitely something to work on. So I showed you in the two bats that I did model, that the width of the sweet spot was a little bit bigger than on the torpedo bat than on the standard bat. And could one go further? Probably yes, but I don't know. I don't know for sure. It's definitely worth something, worth modeling that and trying to build something like that.
I'd love to jump in here with some strongly held opinions on, and I didn't share with you guys these colors. So let me share with you these colors. These colors are, if you talk to a bat rep, they'll tell you, this is the sweet spot on the other guy's bat, and this is the sweet spot on our bats that we sell you. And then I have to go in and say, hey, no matter who's making the bats, there's one location that performs the most. And we can talk about how it's the intersection between the center of percussion and the second bending mode of vibration. But what really matters to the hitter is, what am I aiming for? And we can tell them that, and we make sure they understand that as impact location goes this way, performance goes down. As impact location goes this way, performance goes down. So it's not like a plateau of amazing performance through the length of the barrel. It's a mountaintop of performance. Kind of like the graphs that Dr. Nathan showed. It's one location that outperforms the rest of the barrel. Let's give that information to the player. And let's also, we've got all this data on impact location now. Let's match those up and give the guys a bat that matches well with their highest, most frequent point of contact. And I think that's what we're seeing has already been done with some of these guys who were the early adopters with the torpedo bat.
I've got one more technical question, and then we'll close up. So when we were talking about the bats that Dr. Nathan received at his lab, Alan, you mentioned that it seemed like the moment of inertia was roughly the same in the two bats. But question from Hillary here is, if the mass distribution of the bats is different, how is the moment of inertia the same?
Densities are different. The density of the wood is different for the two bats. Yeah, it's a good question. I
That's a great
thought
question
about that myself, and then I realized that the density was slightly different. So the actual swing weight of the bat is almost identical, assuming the density is uniform throughout the bat.
We see something very similar in the lab. You've got two bats that are volumetrically identical, made on an auto lathe, so they're the exact same shape. They take up the same space, and we see wildly different, not just the distribution of mass, but the balance point and all these other things, very, very pretty widely. And it's like, well, they're the exact same shape. How could it be? And it's because the bats were made of billets that are of different weights, and that speaks to the density comment from Dr. Nathan. So a lot to manage. Just to get the player a consistent product from the get-go.
Got it. So to close this out, I would love for each of you to share how you would describe a torpedo bat to someone for the first time, right? And then what you are looking forward to following the rest of this season with this equipment. And Jed, you can lead us off if that's all right.
Yeah, I mean, in my mind, the torpedo bat is it's another model, right? Like, you've got all these different models that have been spun throughout the history of baseball, and it's another model, and it's another opportunity for a player to find what works for him.
Awesome. And what are you looking forward to following with it the rest of the season?
The torpedo bat specifically?
Yeah, or if you have something more general about the season.
Well, I mean, I think Yeah, sorry. I mean, the torpedo bat in general, I think, you know, just to see if some of these early trends that we've just talked about hold through the course of the season, because there's a lot more human element involved in the game that hasn't been factored for yet.
Gotcha. Great. Keenan, what about you?
I would describe the torpedo bat phenomenon as we now have one other way to change the bat parameters to customize them and suit them to the individual hitter. This is another one of many, many ways. And there are other ways that are less dramatic, less visible. But it's definitely one of the ways that dramatically changes all of the various bat metrics we talked about. I would say the thing I'm most excited about for this season is the continuation of the hitters adopting advanced bat data. So it's not just length, weight, and turning model anymore, guys. It's all these other metrics that come together to determine what that individual bat is going to do in your hands. How is it going to affect your swing speed? But beyond that, how is it going to affect your kinematic sequence? And then, of course, how does it affect the resulting exit velocity or contact quality that you can get with that individual bat? And the reason I'm so excited about it is we've seen the balance of power in baseball swing towards the pitchers because they adopted advanced data years and years ago. And we saw the ones that adopted it early had great success. I'm excited to see how the hitters react now that we're able to arm them with this data. And it seems like some of them really are picking it up. So it's great.
Dr. Nathan.
Yeah, so I would describe the torpedo bat as like other people have also as like a bowling pit, if you had to just come up with an analogy. A couple of things for me I'm looking forward to. I'm certainly looking forward to the measurements that I'm going to do, myself and my colleagues, to see how these bats perform in the lab. And a lot of people have suggested that you get higher exit velocity with such a bat. I would like to see evidence for that. The second thing I would like to see actually in baseball is how the pitches adjust to this. And whether, for example, you start to see them throwing more sweepers to the outside, that'll be more difficult to hit, as opposed to pitching inside. So, baseball's a game of adjustments. Pitchers do one thing, batters adjust. Batters do something, pitchers adjust. And the interaction there, I would find very, very fascinating.
Excellent. Excellent. Thank you all so much. This was a absolutely entertaining and informative panel. Really appreciate you taking the time. Looking forward to the 2.0 version of this when Dr. Nathan has a robust data set and we've got a full season of data from on the field as well. So thanks again to Keenan Long, Jed Lowrie, Dr. Alan Nathan for joining us tonight, and thanks to all of you for joining us as well.